Okay, so here is for you to understand. I try my best to animate. Okay. In the case, first, okay, initially, we have dry air and we have water, liquid water in a tank. And then initially the dry air, the gas phase, okay, it contain no water. So there is no water here. It just solely a air. Okay, it's a dry air. So the vapor pressure of water is equal to 0 initially. After some time, the water will start to evaporate. Okay, the water will begin to evaporate and the water molecule will escape from liquid into gas phase. Okay, so the mole fraction or the mass fraction, okay, why we always see the symbol Y we use for mole fraction in gas phase. Mole fraction in gas phase. Okay, so the mole fraction of water in a gas phase will be increased because the water start to evaporate. And same goes with the vapor pressure of water. Okay, so initially it is at 0 and it continue to increase from some time because the water is start to evaporate. Until one time, okay, until one time saturation occur. What is saturation? Saturation meaning to say the water molecule no longer can enter the air because the air is saturated, is full. I believe you always use this sentence. I'm saturated. Okay, when you learn this, you might be saturated also. Okay, at a time whereby the water molecule cannot no longer enter the air, and that is called a saturation. Okay, so at this saturation, the vapor pressure at that time is equal to the pure vapor pressure at that particular temperature. Okay, so this system occur at temperature 75 degrees C and 180 M. Okay, so at this constant temperature and pressure, this is what happened. Okay, so at this condition, whereby at the saturation, any attempt to increase partial pressure akan menyebabkan the water will start to condense, or we increase the pressure, the water will start to condense. And then this condensation only occur when the water is already saturated in the air. Okay. And then this condition, the water in the gas phase is also referred as saturated vapor. Because it's saturated, we name it as the saturated vapor. Okay. Initially, we have just dry air and water liquid. So the water start to evaporate into a gas phase until one time this air is full with water, then it is saturated with water. So if you add more vapor into this air, it will condense. Same goes when you increase the pressure, the condensation will occur. Okay. I really hope that you can understand what happened here. Okay. Another term is superheated vapor, whereby this superheated vapor meaning to say it's in the middle. Okay, it's not yet saturated. The vapor pressure of water is less than the vapor pressure, the pure component vapor pressure. Okay, it less than. Okay, because of this condition, okay, at this condition, we do understand that the water can evaporate more, right? The water molecule can evaporate more, can still enter the water, the gas phase. But at this point, what if we want a condensation to occur? Okay, we want condensation to still occur here. Okay, previously after saturated baru dia condense. Sekarang ni kita nak dia condense sekarang juga. Okay, dalam keadaan dia superheated. Okay, so I want to explain to you what is the difference between saturated and superheated. I want you to understand the difference between saturated vapor and superheated vapor. Saturated vapor, saturated, meaning no longer can accept any water molecule. But this superheated, it still can, the water molecule still can escape, still can enter the gas phase. But we want a condensation to occur here. So there are two methods in which we can condense. Okay, although it is in superheated, we can condense this water into gas phase again. We want it to condense. Why we need to condense? Because in some cases in chemical industry, they want to do a separation process. Okay, we cannot wait until saturation occur. We just want to separate at any temperature and pressure. Okay, the first method is we use condenser, in which we reduce the temperature. Okay, as you can see here, okay, initially the temperature is 100 degrees C, so we reduce to 80 degrees C. We reduce the temperature by using a condenser. Later on we will learn what is condenser, not in this subject, later on maybe in a heat transfer subject. Okay, so we reduce the temperature so that the water vapor will start to condense until we reduce the temperature until one point whereby the water starts to condense. At that temperature, we call it a dew point temperature. Okay, and if we reduce further than the dew point temperature, all the water vapor will condense into the liquid. Okay, faham ke tak ni? Cara ni ialah kita turunkan temperature menggunakan condenser. Okay, kita turunkan temperature sampailah semua water dalam gas ni, dalam vapor ni dia condense. Okay, kita turunkan temperature tu sehingga satu masa water start to condense. Bila dia condense tu, temperature itu dinamakan dew point temperature. Dew point temperature. Okay, ini ialah cara yang pertama. Okay, this is the first method. Okay, the second method is we compress, which is we increase the pressure. Okay, we increase the pressure. Okay, P2 here is increase further the pressure. Kita naikkan pressure pula, and the water vapor will start to condense. Okay, I really hope that you can understand this. This is the method that we condense. We want the method in which we make one of the species condense from gas phase to a liquid phase. Okay, ini ialah method di mana kita melakukan kondensasi. Okay, kondensasi Di mana mana-mana spesies kita nak bagi dia condense daripada gas kepada liquid. Walaupun keadaan dia ialah superheated. Okay. Kalau keadaan dia saturated macam sebelum ni, dia dah memang akan condense. Okay. Dia akan senang untuk condense bila dia saturated. Cerita sekarang ialah kita nak dia condense dalam keadaan dia superheated. Okay. So, kamu kena faham apakah saturated vapor, apakah superheated vapor. Okay. Kalau saturated, maksudnya dia dah penuh. Okay. Dia dah tak boleh nak terima dah water molecule. Kalau superheated, dia masih boleh terima, tapi kita nak dia condense. Okay. So, we go to the next example. Okay. In this example, you have a stream of air at 100 degrees C and this pressure 5260 mmHg with 10% water by volume. Okay, what you need to do is you have to calculate a dew point. Okay, the temperature in which dekat mana dia start to condense tadi, temperature tu. Kemudian the degree of superheat. Okay, I forgot to introduce to you this one. Okay, the degree of superheat meaning to say initial temperature minus final temperature. Perbezaan ini dinamakan degree of superheat. Okay, so kamu kena kira ni. Yang kedua, you have to calculate the percentage of vapor and final composition, which is the Y. If the air is cool from 100 degrees C into 80 degrees C. Okay, boleh relate dengan previous slide. Okay, and then in this case we reduce the temperature, which is we using a condenser. Okay. And then the third one is you have to calculate the percentage of condensation and the final composition Y. Okay, if the air is compressed, okay, we increase the pressure. Okay, so what happened to the final composition? What happened to the percentage of vapor condense? Okay, so macam mana nak kira? Okay, the first one is, okay, the first thing what you need to do is, okay, the first thing ialah kita kena refer to this table B3, which is a vapor pressure of water. Okay, this vapor pressure of water at specific temperature. So the first one kita refer kepada kita nak cari the first one, kita menggunakan formula ni. Okay, partial pressure sama dengan mole fraction darab total pressure. Okay, kita guna formula ni, kita ada 0.1%. Jadi by volume that fraction tu kita darab dengan total pressure. So kita akan dapat this partial pressure. And then kita kena tengok dekat table B3. Okay, tengok dekat table B3. At 100 degree C, what is the pressure? Okay, the vapor pressure at 100 degree C, which is 760 mmHg. Okay, keadaan ini ialah keadaan superheated. Okay, sebabkan ini, sebabkan nilai partial pressure 526 ni lebih kecil daripada 760. 760 ni ialah nilai yang sepatutnya, maksudnya nilai maksimum, nilai saturated vapor. Okay, partial pressure saturated vapor pressure. And then this condition now is only 5 to 6, which is lower than 760 ni. Okay, tak apa, calculation ni just nak menunjukkan this vapor is superheated vapor. Okay, this vapor is a superheated vapor. Kemudian kita nak cari dew point ialah dengan refer kepada table B3, which is kita kena cari pada kita nak dia saturated, kita nak dia jadi dekat temperature berapa yang dia boleh jadi sama macam ni. Dekat temperature berapa nilai partial pressure akan sama dengan nilai ni. Okey, nilai sebelah sini ialah 526. Okey, tapi dekat temperature berapa? Which is dekat 526. Yang ni kita tengok je directly dekat table ni, kita tengok 526. So kita dapatlah dia punya dew point ialah 90. Okay. Kemudian degree of superheated kita tolak je lah. 100 tolak 90. Okay. Apa maksud ni? Macam pening je kan? Okay. Ulang balik. Saya pun pening nak explain dekat kamu. Okay. Yang pertama kita cari nilai PI, which is a partial pressure. Okay. In equation is given to you the value of Y, which is 0.1. Okay, dia dah bagi nilai mole mole fraction. Dia bagi nilai apa? Okay, 10%. Okay, water by volume it still can be considered as a mole fraction. So, ambil je nilai tu 0.1, darabkan dengan total pressure. Total pressure which is 5260. Okay, so kita cari partial pressure dulu. Partial pressure dalam keadaan 100 degree C dan dalam keadaan 5260. Apa dia punya partial pressure? Okay, that is the first. So kita dapat nilai ni. Okay. Saturated. Okay, saturation berlaku pada suhu 100 degree C dekat pressure sebanyak 760. Tapi pressure yang kita ada sekarang ialah hanya 526, which is lebih kecil daripada 760. Jadi, dia ikut formula yang ini, which is vapor ni ialah superheated. Itu je dia nak bagi tahu sebenarnya. Untuk kira dew point pula, untuk tentukan dew point temperature, which is temperature yang mana dia start to condense, kita kena refer kepada table B3. In this table B3, okay, table B3 ni, just cari sahaja apa kita punya partial pressure, which is kita dah kira tadi. Okay, kita cari kalau nilai pressure ni dia berlaku dekat temperature mana. So kita tengok dekat sini, dia berlaku dekat temperature 90. Okay, dia berlaku dekat temperature 90. Jadi 90 lah dew point. Okay. Nah, tu je sebenarnya. Jangan confuse teruk sangat. Okay. Just calculate je dulu nilai partial pressure. Okay, partial pressure. Okay, kamu jangan confuse teruk sangat. Nilai vapor pressure. Okay, adanya partial pressure. Adanya total pressure. Okay, so kamu kena bezakan simbol-simbol ni. Okay, kalau total pressure P besar, partial pressure ialah P, tak ada star. Vapor pressure lepas ni ialah ada banyak P star. Sebab kenapa ada P star? sebab dia dah saturated. Okay, and sebab dia pure component. Yelah, tak payah fikir banyak-banyak lah. Okay, so cara dia kamu cari je, okay, partial pressure ni, cari dekat table ni, tu dapatlah nilai temperature. Okay, kalau tak faham tengok banyak kali. Okay, so itu kita dah jawab lah soalan nombor 1. Tentukan apa dia punya dew point temperature dengan tentukan degree of superheat. Yang kedua, okay, number 2, when we reduce the temperature. Okay, we reduce the temperature from 100 degrees C to 80 degrees C, some of the water start to condense. Okay, and this occur in dalam equipment yang bernama condenser. Okay, so macam ni tadi, dia dah bagi nilai 0.1 mol, okay, water dengan selebihnya ialah air lah. Okay, 0.9 dry air. Dekat pressure tak berubah. Okay, temperature je berubah. Okay, daripada 100 jadi 80. Kita cool down. Okay, because we want it to condense. Okay, so cara dia sama juga. Dekat 80, terus baca dekat table B3, apakah nilai vapor pressure dekat 80. Terus baca vapor pressure at 18 degree. 18 degree berapa? Okay, kita baca je terus. Dapat nilai ni. Okay, bila dapat nilai ni, kita boleh kira apakah nilai Y menggunakan formula ni. Okay, kita boleh kira nilai Y. P sekarang ialah dekat 5260, betul? Dan kamu kira nilai ni. Nilai ni dapat daripada table. Okay, nilai ni dapat daripada table, which is 355.1 or 355. So kita just bahagikan, dapatlah nilai Y. Senang je kan? Okay, sebab dia nak tahu apakah nilai final composition, which is nilai Y lah. Okay, and then yang kedua kita kena buat balance on dry air. Okay, balance on dry air ni sama macam kamu buat balance sebelum ni. Okay, which is 0.9 darab 100 sama dengan yang keluar. Okay, 1 tolak Y darab N2. Okay, so nilai Y dah ada daripada atas ni. Masukkan, dapatlah nilai N2. Okay, kemudian kita buat total mole balance. Okay, 100 yang masuk. Okay, 100 yang masuk sama dengan, oh saya letak dua-dua N2, silap ni, sini N1. Okay, so N1 dengan N2 yang keluar. Okay, so dapatlah nilai N1, which is berapa banyak water condense. Okay, sebab kita nak cari percentage of condensation ni. How much the water is condensed. In term of percentage. Okay, so berapa banyak yang condense over berapa banyak yang masuk, darablah 100. Okay, mudah je kan? Okay, dapat je soalan, kamu cari dulu table. Okay, apa maklumat yang kamu boleh ambil daripada table, which is nilai ni. Okay, this is from table at a given temperature. Okay, mesti pada temperature tertentu. Okay, kemudian kita jawablah soalan nombor 2. Okay, soalan nombor 3, if you have a compressor. When you have a compressor, okay, we increase the pressure. Pressure is increased. When we increase the pressure daripada P banyak ni kepada lebih banyak, okay, the first step again, you have to take a look on the vapor pressure at 100 degree C. Okay. Vapor pressure at 100 degree C berapa? Divided by, ni dekat sini lah. Divided by 5260, you akan dapat mole fraction. Okay. Kemudian sama juga buat balance on air. Okay, berapa banyak air yang masuk. Okay, dry air. Okay, dry air yang masuk kepada dry air yang keluar. Okay. Saya rasa yang ini sepatutnya nilai dia yang ini. Saya rasa lah. Kena cek balik. Tak silap saya dia kena nilai yang inilah. Sebab ini menunjukkan final condition. Y ni. Okay. So yang ni tukar salah ni. 850. Okay, tak apa, nanti saya cek balik. Okay, kemudian buat balance on air, kita akan dapat nilai N2. Simple je balance ni. Jangan risau. Okay, kemudian kita buat total balance, kita akan dapat nilai N1. Which is lebih kecil, cuma 12%. Compare kita buat, kita cool down tadi. Okay, dia cuma 12%. Okay. Okay, so example ni kamu boleh refer kepada diagram sebelum ni, which is apa yang berlaku kepada molecule of water tu bila kita compress ataupun kita masukkan, bila kita cool down dia punya temperature. Cool down maksudnya reduce the temperature. Okay, and then this is another formula, okay, that related to this system. Okay, and then you just going to use directly the formula. Okay, macam mana nak guna this formula? We take a look on this example. Okay, in this example, you have humid air. Okay, meaning to say a mixture of air and water, humid air, at temperature 75 degrees C and 1.1 bar with relative humidity 30%. Okay, apakah relative humidity? Tengok balik formula sebelum ni. Which is this one. Okay, nilai HR ataupun SR 30 dia bagi. Okay, and fed into a unit, a process unit pada rate 100. It should be meter cube kat sini. Okay, tertinggal meter cube. Okay, so macam ni lah. Dia cerita pasal feed stream sahaja. So dia suruh kamu kira molar flow rate, okay, which is the value of molar flow rate. Berapa molar flow rate of water, air and oxygen yang masuk. Yang kedua, kira molar humidity, absolute humidity, percentage humidity. And yang ketiga, kira dew point. Okay, molar humidity, absolute humidity ni memang guna sahaja formula dekat sini. Okay, guna formula ni dan formula ini. Okay. The first thing to do is you have to do a unit conversion. Okay, because all the table using mmHg. Okay, and then kat sini dia bagi unit bar. So you have to change the unit first. Okay, change the unit first, which is yang ni lah, kita tukar unit. Okay, so ni nilai P. Nilai P, ini kita tukar unit. Okay. And then daripada table, nanti kamu tengok sendiri table ni. Saya pun dah tak muat dah nak sumbat kat sini. Daripada table ni kamu tengok pada temperature 75 degree C, apakah nilai vapor pressure dekat temperature tu. Okay. Dia akan dapat nilai ni sepatutnya. Okay. Kemudian Kemudian ialah daripada nilai 30% yang dibagi dalam soalan tu, guna formula ni, guna formula ni untuk dapatkan berapa persen of mole fraction of water. The mole fraction of water ialah nilai ni. Kalau 30% maksudnya partial pressure of water dalam sistem tu ada sebanyak ini. Kemudian kamu bahagikan dengan 825 which is the total pressure. Yang ni nanti dulu. Yang ni kita akan guna next. Nanti confuse pula. Yang pertama tukar unit. Yang kedua daripada 30% relative humidity ni, kamu masukkan dalam formula dia. Masukkan dalam formula P I over P star T ni. You will get the value of this. And from this, you can get the value of Y. P. Which is this. That is the first. Yang ni nanti, ini kita nak guna untuk next. Next ialah conversion unit sekali lagi, which is the unit temperature and the unit of temperature. Kemudian, because this is a gas, you can still use PV equal to nRT to determine the value of N. So, at pressure, sebab the information given to you yang diberi ialah nilai volume. The volumetric flow rate is given so that you can calculate the value of mole flow rate by using PV equal to nRT. And be careful with the unit of R because it is bar. And then the unit of liter here, and this is meter cube. Ada beza lah. Jadi kita dapat nilai N. Kita dapatkan nilai N. This nilai N ialah kita guna PV equal to nRT sebab kita ada tiga information ni. Kita dapatkan nilai N daripada PV nRT. And then nilai Y pun kita akan dapat daripada formula ni. Kemudian kita nak cari mass flow rate of water, mass flow rate of dry air and then mass flow rate of oxygen. Lepas kita dapat nilai N, kita darab je lah. Y darab dengan N dapatlah untuk water sahaja. And then untuk dry air sahaja. Dan dia nak untuk oksigen. So we assume dry air ada 79 nitrogen dengan 21% oksigen. Sebab itulah dekat sini kita guna 0.21%. So kita dapatlah nilai setiap water, dry air dan oksigen yang masuk. Sebab dia nak molar flow rate. And then the molar humidity, which is just use the formula directly. Just use the formula directly. Nanti je. Untuk water. And then untuk absolute humidity, formula dia kena darab dengan molecular weight. Molecular weight of water dengan molecular weight of dry air. Jadi dapatlah nilai ni. Ni masukkan dalam formula sahaja. Begitu juga percentage of humidity pun sama. Masukkan dalam formula sahaja. Start dengan yang atas ni. Which is value yang atas ni dapat daripada yang ni. Yang atas. Yang bawah ni kamu kena kira. Kamu kena kira. sebab dia pada temperature yang berbeza. Okay. Baru perasan 298 ni guna dekat sini, which is kamu dah baca tadi dekat table. Okay. Banyak sangat conteng ni pening kamu. Okay. Okay, this value from table. Okay. This value from table. Okay. And then this one daripada previously. Okay. This is bila you kira tadi. Okay. And then total pressure tolak dengan mole fraction dia. And then bila ada star ni, memang directly daripada table. Masukkan dalam formula ni. Okay, ni yang bawah star ni kamu kira. Ambil nilai ni daripada table. Dan nilai ni pun daripada table. Malah masukkan dapat nilai ni. Kemudian bahagikan sahaja. Okay. Next ialah nak kira dew point macam tadi juga. Bila nak kira dew point, bila nak tentukan dew point, terus refer kepada table B3. Okay, so table B3 refer. Cari je pressure ni. Okay, cari je pressure ni. Which is dekat sini. Okay, bila dapat dekat sini, drag sehingga drag ke kiri untuk tengok berapa temperature, which is 48, dan drag ke atas which is 7. So dapatlah nilai 48.2.